All right, so I don't know if I'll walk through all of these or not, but this is a retrieval. Rewrite each of these in vertex form. So 3 practices of vertex form and a couple in factored form. I'm gonna do 3 and I'm gonna do 4 because that'll be helpful. We should be able to follow the 3 steps, okay? Step number 1, divide A, move C. So divide A out of the first 2 terms and move C. 8 divided by 2 is 4, so plus 4x plus something, and move 15. Here I'm dividing by 1, it's not going to change anything. Take half the middle value, so 4 divided by 2 squared equals 2 squared, which is 4. And then if I write vertex form, again, it should be f of x or y. My a value, I'm looking for a, h, and k, right? There's a. Here's where h is going to go, and here's where k is going to go. Is it going to be x plus or x minus? Well, my new b value is going to tell me that. It's going to be plus. What I take half of is going to be my h value. And then over here is my k value. What's that going to be? Well, 4 goes in the blank right here. That's for 1 perfect square. But how much am I really adding? I'm really adding 8, so I must subtract 8. So what's 15 minus 8? That's going to give you plus 7. Negative 2, positive 7. That's my vertex stretch of 7. So there you go. Rewrite each in factored form. Multiply A times C. I'm going to factor this one by grouping because that's what we should always do. Factors of 56. 1 and 56. 2. Will 2 go into 56? Hey, if you forgot, you're going to use a calculator. You can use a multiplication table, or you can divide old school. 28. Will 3 go into 56? Again, use a calculator, divide old school. Will 3 go into 26? 3 won't go into 26 evenly, so I don't think it will. 4, will 4 go into 56? And not that I'm going to cheat, but I'm just going to grab a calculator here so as to make things easier on all of us, right? So clear, so 56 divided by 3, 56, oops, 59, 56 divided by 4 gives me 14. 5, will 5 go into 56? I doubt it. No. 56 divided by 6, no. 56 divided by 7 is 8, so 7 times 8. 8 will, 9, 10. There, I found all my factors of 56. Which ones give me 15? 8 and 7, so that's x squared plus 7x plus 8x plus 56. Told you I was going to factor by grouping. I should get x plus 7 and x plus 8. That's what I'm predicting. Group the first 2, group the last 2, divide x out. I should get x plus 7. The second set of parentheses should be x plus 7. Divide 8. How many times will 8 go into 8? Once. 8 goes into 56. So x plus 7, x plus 8. There's your answer right there. You do the same thing the other way. So there's the ready. Now, for the ready, here's the focus of this, okay? And I'm going to cover this in class, and then we'll do the other stuff. A golf pro practices a swing by driving golf balls off the edge of the cliff. You see person's driving golf balls off the cliff. It's given by the function 58.8 plus 19.6 t minus 49 t. The expressions shown are equivalent. They tell me all of these are the same. It even tells me what form they're in. Standard form, factored form, vertex form. Alright, so picture this. We got our lake, we got our cliff, person hits the golf ball goes up, golf ball comes down, splash. Right? Which expression is most useful for finding how many seconds it takes for the ball to hit the water? Any ideas? Well, think about it. Along here is my x-axis. What would we call or identify that point? Wouldn't that point be identified as a x-intercept? If you think of it graphically, not as in the context of the picture. Okay? What form is good for x-intercepts? Factored form. Which expression is the most useful for finding out how many seconds it will take for the ball to reach its maximum height? What point on the graph, where would its maximum height be? Its maximum height would be somewhere up here, right? What would we call that? Well, that point right there is going to be a vertex. So it's going to have an x and a y value. G, vertex form. The ball went 78.4 feet high. Vertex form. Which expression is most useful for finding the maximum height of the ball? Vertex form. That's going to tell you the maximum height, right? Not to mention the vertex, okay? Sorry, and I kind of goofed on that one. Number 3, how many seconds it takes? Well, it takes x seconds for a y height, okay? So x seconds for a y height. So at 2 seconds, it's going to be 78.4 feet high. If you wanted to know the height of the ball at exactly 3.5 seconds, which expression would be the most helpful to find the answer? Which expression? Think about it. I know x is 3.5. Which one of these? If I plug 3.5 in here, here I got to do it here and calculate, or I could plug it into here. The question, or the answer to the question, is any of them. Think about it. I have an x, an input value. I just got to find an output value, whichever one you find easiest. And if you want to know the height of the cliff above the lake, which one would you use? Well, here's the height of the cliff, okay? Assuming that the cliff is actually closer to here, what would that represent? Okay, this needs to move over here. I don't like this. I wish this picture was slanted over here. Here should be the cliff. All right, that's what that should be. Come to think of it, I'll have to change my answer tomorrow. So the cliff should be right here. Then the ball will go up and come down. All right, just imagine that moved over a little bit. All right? What is this point right here? That point right there is a y-intercept. So which one of these equations helps you find the y-intercept? Well, C. The answer is C, which is standard form. Okay, so there's a little bit of an application process for helping out with this. Hopefully you get the ready done.